right, good evening. So my name is Jim Small, and talk to you about Git and GitHub. And never heard of you before. So I've worked in IT since '95. Worked in most areas of IT. I've worked in compute with Unix, NetWare, Windows, Linux, BSD. Done a fair amount of virtualization, mostly with VMware, and a fair amount of networking with Cisco and open source. And lately, I've actually been getting back into scripting. So actually, the first operating system I learned was Unix, was actually Sunos, which is BSD based. And I used to be a major shell scripter. But then in Windows, I kind of got away from it, and now I'm trying to get back into it with Python. And actually, as part of that, I went to Ohio in July. Craig was also there. And as part of my kind of journey in Python, one thing that comes up all the time is Git and GitHub. So I'm going to kind of talk about what you can do with them and why they might be useful. So the first question I have is, how many people have extra time? Anyone? Okay, that's what I figured, right? So, I wanted to start with, why would I want to learn another tool, right? Because nobody has time. There's already too many tools. There's too many interesting things. And Git was on Git and GitHub. I mean, I heard of this for years. I'm sure you all have, right? And I'm like, yeah, that'd be really cool, but I just never got around to it. And I have to admit, the only reason I actually started using it is because I took a class, and as part of the class, they forced us to actually do our homework using Git and GitHub, which actually turned out to be a great thing. I'll talk about this, but it turns out when I took the class, my computer actually, my hard drive failed, totally died. And fortunately, all my homework and notes were on GitHub, so for the class it didn't impact me. So that's an example of using some of these technologies can be really helpful, especially in terms of synchronization. You can use multiple devices. We'll get into that later, but it can definitely be a nice tool. And I also want to spend a little bit of time talking about, so, you might have an idea about why you use these, but what specific problems would they be helpful for, right? What kind of scenarios would they be interesting in? Okay, so, how many people have at least heard of source control or version control or some kind of file management system? Okay, so most people. So I'm going to talk about it a little, but the idea is that if I have one or more files, if I use source control or version control, it's basically a system that can monitor the files and monitor changes. That's the basic idea. So if I'm working on code, source code, if I'm doing scripting, if I'm doing, a website, anything that's text-based. Actually, you can use it for binary data, although it's not really what it's designed for. It's really better for text data, but that's actually a lot of formats work in text, right? So anything that I can do in text works really well with this. And where it's useful is, especially for anything like any kind of script code or any kind of configuration, like if I'm doing something in my infrastructure. So the problem we typically run into is we're doing something, doing some kind of a script or code, doing some kind of infrastructure configuration, and then we run into a problem, right? We hit a vendor bug, there's a security issue, there's an urgent change, and then we change something and it breaks. And then that breaks, and of course when you do it, it's like late at night, you're under the gun, so then you keep making changes, and now it's like, where did I start from? And maybe you have a backup, maybe you don't. I also, right now for my day job, I'm a consultant, so I can't tell you how many customers I go to and they're like, don't worry, we have a backup. Check the backup and hasn't worked for like 6 months, right? Very, very common. So, large companies are usually better, but not always. Right? It's still a very common issue I run into. So, this can be really helpful in terms of if you use something like this, it's going to force you to basically have some kind of a backup and some kind of a known good version. The other thing is, what if I want to do testing? Right, so typically if I have any kind of infrastructure or development environment, I want to have some kind of like a stable branch that I know just works. Maybe I want to have something for my lab. Maybe I want to have a model office, something for the future, you know, for testing new features. So this makes it easy to do that. And then also, even for things like working on a presentation or a website or something like this, if I can use a text format like Markdown, I'll talk about that later, then it makes it really easy for me to collaborate with people and see who's doing what. Okay, so when I use, the idea with any kind of source code or version control system is I can basically check stuff in. So when I use the tool, I have a file, I check it in. When I check it in, it's going to record who I am, it's going to record the date and the timestamp, and if there's a file already there and I'm modifying it, it's going to tell me what changed. So this can be really nice because I actually have a history of everything that's been done. Also, if I follow best practices, every time I check in a file, I'm going to put some kind of comments in that should say, this is what I did. You know, this is why I made a change, or yada yada. And that gives me a history, so I can basically see what I've done, and I can see what other people have done, and kind of follow the trail. Okay, the other thing too is, and we'll have some examples of this, is with some kind of a source control system like Git, it makes it easy for me to switch back and forth, right? So if I made some changes and they broke something, it's easy to revert back. If I want to start from a known good configuration and try some changes, it's easy to do that. If I have 5 people all working on it, they can all basically collaborate at the same time. You know, even if they're doing conflicting things, it's designed to deal with that. So this makes it really easy for a group of people to actually work through something. And the other thing too, and I'm guilty of this, how many people do document collaboration or coding or configuration with email?
Oh, yeah.
Only one? A few, 3 people? I have to say I'm a little skeptical of that, but this is a much better system than using email. Okay, so Git and GitHub are not exactly the same thing. So Git came first, and then GitHub came later. So GitHub is basically a cloud repository, right? And of course, you know, any interesting technology, we have to have a cloud version, so this is it. So the idea of repository is basically, it's almost like a file, like a file share or somewhere to store stuff. That's all it is. So when I create a repo in any kind of source control system, it can be local or it can be remote. So GitHub is basically just a remote storage place to keep my stuff. And I can keep anything there. And it has all the same features, right? It can track who does what, it can do collaboration, it supports issues, it has all kinds of cool tracking and graphs, makes it easy to search for other projects. So it has a lot of nice features that make it easy to use, and it's also, if your project is public, it's free, which makes it kind of a nice place to start. The other cool thing about any kind of a cloud service is it's easy to link it into other stuff, right? So for example, let's say I have like a web framework or some kind of a program or a scripting system, and I have a team working on it. I can basically, when people check in a change to GitHub, I can basically say, okay, every time somebody checks in a change to this, you know, web system or to this script, I'm going to basically run it through a test. And the test is going to do a whole bunch of stuff, and then it's going to come back and it's going to tell me, did I pass all the tests? And if I didn't, it's going to show me exactly what failed. So this is the idea of continuous integration. It makes it easy to hook this in so that every time somebody makes a change, I can do all of my sanity testing to make sure that nobody broke something obvious, right? So the cool thing about something like this is it makes it brain dead. I don't have to think about doing testing. It's just done in the background. So that's kind of a nice feature too. Okay, so there's this is probably part of why it took me a long time to use Git and GitHub, because you know there's BitKeeper, there's Mercurial, there's all these other solutions, so maybe one of them is better, maybe I should research it, maybe I should look into it, and then what happens, you never have time, so you end up using nothing. So I spent a little bit of time, why, if these features sound interesting, why would I want to use this over something else? And in my mind, there is something with the wisdom of crowds. Now, I'm not saying I always agree, But if I look at something and the majority of people use it and the majority of people are happy with it, there's probably something to it, right? So when I look at Git and GitHub, I mean, virtually every major project out there uses this. If you look at the repo ranking, in terms of like the top 100 projects, I mean, it's unbelievable. I mean, this is pretty much what everybody uses. And we just mentioned Vim. That's actually what I like to use for a text editor. So that uses it. Pretty much all of your JavaScript frameworks use it. Ruby on Rails, the Linux kernel, I mean, that's why it was created. So I mean, you know, these are things that I'm familiar with. You know, I don't know if you're familiar with all of them, but there's just a ton of huge global projects, and they all use this. So there's definitely something to it. So in terms of just briefly, where did this come from? So that basically, this all came out of Linux. And I found this kind of interesting. I'll keep it brief. So basically, originally with Linux, they were actually doing everything over email with patches. And that was really a pain. So I think it was around 2002, they're like, this is nuts. We have to have some kind of a version control system. And they started using BitKeeper. So BitKeeper was pretty good. It was a pretty good distributed system. But the problem was it was still proprietary, and it still had some performance issues. And because it was proprietary, some people didn't like it. So there was kind of this discomfort factor with a lot of the core developers for the kernel. So in 2005, there's a gentleman, Andrew Trudell, I don't know if I'm saying his name right. He basically decided, you know, that I'm going to reverse engineer the BitKeeper protocol. And the person who created and owned it, Larry McVoy, he was very unhappy about it. So the two of them got into kind of like a long fight. And Linus, in the meantime, is trying to moderate between these two and you know, find some kind of a peace forward. And he finally got fed up. And it was funny because before this, when somebody asked, you know, Linus, what do you think about source control? He said, you know, I don't think about it. It's totally boring. It's totally uninteresting. He was kind of ribbing. He doesn't like databases, so it's like maybe it's not as bad as databases, but you know, whatever. I don't want to deal with it. But when this came up, he finally said, you know what? This is ridiculous. This is not that hard. And he just decided. He spent a weekend and he created Git. He actually took about 10 days. That's pretty good programming skills. He took about 10 days and he came up with a working version of Git and did his first kernel commit. So this was back in 2005. And when he was interviewed about how he got the name, he basically said a Git is basically an unpleasant person in British slang. And he said, I called it Git because I'm an egotistical bastard and I like to name everything after myself, both Linux and Git. And with his kind of good sense of humor. So that's where the name comes from. And basically, I guess like a lot of things, necessity is the mother of motivation. So the cool thing about that is, because it was created for the Linux kernel, it is ultra scalable. Because the Linux kernel is arguably one of the most complex distributed projects of all time. So I mean, if it can deal with that, it can pretty much deal with anything. A few years later, basically some guys came along and they created GitHub. You know, basically, like I said, it was a remote repository, has a nice web front end, had a lot of nice little features, and the two kind of got lumped together, and that's how we have it. All right, so another cool thing about Git and GitHub is they pretty much work on everything. So I mean, there's other operating systems, but you know, the most popular, Windows, Linux, and OS 10 or Mac OS, they're all well supported. So in Linux, in OS 10, it's built in Windows, you have to get it, but it's trivial to get. And I know a lot of people are not Windows fans, but if you do deal with Windows, since PowerShell has come along, PowerShell is actually a pretty slick environment. And if you work in PowerShell, it's a nice shell. It has pretty impressive scripting and programming support. So I'd say it is a workable environment if you use Windows, you know, or the other two, or you can run a VM. All right, just, you know, FYI, there's a lot of great documentation. I'm going to skip by this. Okay, so one of the things I wanted to do, so when I went to Pi Ohio, I got introduced to the concept of a sprint. So how many people are familiar with a sprint? Okay, probably about half. So the idea of a sprint is, if I go to something like a programming or scripting conference, a sprint is I get a group of like-minded people together that are interested in the project. Like maybe it's Vim, maybe it's a website development framework like Django or Ruby on Rails, and we basically work on a common project. And that project is going to have some kind of a repo, typically on GitHub, and there'll be a bunch of open issues, and you'll basically pick an issue and start working on it, right? And you'll all kind of sit there in a conference room, maybe get a pizza and some coffee or whatever, and work late and see what you can get done. That's a sprint. And usually when you go to conferences, especially open source ones, sprints are really popular. They'll usually have them every day, right? So I went to PyOhio, had a bunch of sprints. However, a lot of us, like me, we're pretty new and we're kind of green with this stuff. So it was nice. One of the guys, Chalmer Lowe, he basically ran a session where he walked us through, here's how you use Git and GitHub to actually contribute to a project. And I'm basing this off his example. So like a bunch of us worked to put this together. I focused on GitHub, somebody else did Git, somebody else did like some of the web stuff and some of the applications. But what I'm hoping that when you leave this presentation, I'm actually going to give you a little homework. You'd be comfortable doing all this. You'll actually install Git on your computer, set up a GitHub account, and actually start using it, right? Because if you don't use it, it's kind of like, it's not helping you, your life isn't improving. So that's my hope. So in terms of how I do it, pick an operating system, they're all pretty much the same. I'm going to create some kind of a directory like test. Now, I guess there are some basic things I'm assuming, right? So I'm assuming that when it's installed, it's in the path. There are actually a few quirks there, but I don't want to go into all the details. So assuming Git is in your path, I basically have Git and I have some kind of command. So the first thing I need to do is I need to globally set it up. This is a one-time thing. So as with any distributed system, I need a username and a password, right? So the username and password these are essentially what I'm going to use. This is what I set up on GitHub, right? So I don't strictly have to do this if I just do it locally, but even if I'm not going to use GitHub, at some point I'm probably going to want to have some kind of a remote repo, and if you don't set this up, I think it does like guest or something like that, which is not useful for tracking. So you should at least do some kind of a username or something, right? So you have some way to distinguish. Then you can use git config -l for list, just to make sure you've done it. And then as far as setting up the repository, it's totally easy. I just type git init, right? And these commands, it takes a little getting used to. I kind of made myself a cheat sheet, but after you do it a few times, it's just totally automatic. You won't even think about it. Now, basically, when I do that git init on my system, that creates a .git directory. That directory is essentially, if you really get into it, it's a key value store database that stores everything, but generally we don't have to care about it. It's just where everything gets kept. It's kind of tucked away. Generally, all I care about is, now that I'm in that repository, that repo, now I can basically take files and I can check them in or track them, right? So this example right here is in Markdown. Let me ask a quick question. So how many people have used Markdown? Okay, only a few. So Markdown is kind of like a play on words. HTML is a markup language. So Markdown is kind of a facetious way of saying it's a little simpler. The idea of Markdown is, like if you've ever done anything on a wiki, all wikis use Markdown. So it's kind of a simplified version of HTML. And the idea with Markdown is, because we don't have as many tags, it makes it easier to use, and it makes it very easy to use some kind of a version control system. And actually, with some of the Markdown languages, there's some enhancements. You can make some pretty slick presentations. And the cool thing is, if I, for example, do my slides in Markdown, then it's easy for me to share them with a group of 10 people, right? I know some of you guys are stuck with this. How many people use SharePoint at work and have to try and use that for document management? Right? Who is a SharePoint fan and thinks it's a great document management system? Yeah, I don't think anyone is, right? So the idea of Markdown is, the problem with binary files, like the Office format, is they don't work well in version control. right? And so if you have any kind of a complex document, you have 20 different people looking at it, you really need some kind of an easy way to see who changed what. So that's the idea of Markdown, and that's why wikis use it, is it makes it easy to actually collaborate. So I just kind of did this as a real simple example. I create a notes.md, MD for Markdown, and then basically, as soon as I create a file in this directory, where I did the git init, if I do a git status, it's basically going to say I have untracked changes. In other words, I created a file in the directory and it's not checked in, I'm not tracking it. So, if I actually want to use Git or use the version control system to track it, then I just do a Git Add. Right? So in this case, I'll do Git Add and then notes.md. Now, once I add it, again, if I do a git status, it's going to say it's staged. Let me come back to that in a second. Then I can do a commit. So a commit is basically saying, okay, I am saving this version into my local database or into my repo. Now, the reason, I see a lot of presentations that'll show you how to do this in one step. But everybody I've talked to that's like a more experienced person said, don't do that. So the idea with the staging area is you typically, or frequently, you're going to stage more than one file. You're going to stage a group of related files. When everything that you want is staged, you do one commit, and all those files are committed at the same time. So you typically want to do this as separate steps, because then if you change your mind, it's easy to back out. If you try and combine this and do it quick, my experience is you usually regret it. So there's a reason I kept that as two separate steps, and I don't show how to combine it, because I've never met anybody who said that's a good idea. Now, once you commit it, you're going to notice it comes back with this guy, with this hash value. So I want to talk about this for a second. With Git, it uses a SHA-1 hash for all files. And again, the reason is this, without getting too much into the weeds, is Git is actually a key value data store. So essentially, when I check in any file, that file is basically like, that file is my data that I'm stuffing into the database. And every time I stuff something into the database, it's going to run that SHA-1 hash over the file. It's going to basically use the SHA-1 function to create a hash value. So SHA-1 always creates a 40-byte hexadecimal hash. This is the first 7 digits of that. That hash is basically the key. So if I use that key, if I present that key to the database, it's going to spit back out my file. That's basically a way of indexing or arranging the database. So we'll come back to this later. This is actually a useful thing. Okay. Once I actually commit it, if I do a git status again, it's basically going to say the directory is clean. In other words, I don't have anything that's untracked or anything that's not checked in. As soon as I add another file or make any changes, it'll go back to untracked. So basically, this is totally straightforward. Essentially, I make all my changes, I add or delete files, and then as soon as I'm done, I just git add everything I changed, and then I commit it. And I just want to get in the habit of, whenever I do a commit, for the initial commit, this is okay, but again, I want to get in the habit of, when I do that commit, I add some kind of a useful comment. Just a sentence, not a super long thing, but just enough to kind of trigger your memory, why you did something. Okay, now, as you start using this more and more, because at first it's just kind of like, so what, it hasn't really got me anything useful. As you use this more and more, you can start exploring some of the advantages of version control. So one thing I can do is, as I make changes, I can say, okay, if I do a Git Diff, it's basically going to do a difference between the changes I just did and what's already committed. And basically everything in green, the plus stuff, that's saying this is the new stuff. The red stuff is the old stuff that I've changed. So this is obviously a very easy example. But where this gets interesting is, let's say I have 5 developers that have worked on a script, and now it breaks, right? When somebody checked it in, ran all the automated tests and continuous integration, now the test failed. So I need to figure out, okay, I look at what broke, I find that section of code, or if it's a web framework, I find the part that is having problems, and I can go back and I can do a diff and I can say, okay, who changed this? and what did they change, right? So I don't have to try and open stuff manually and figure it out. I literally just look in Git and it will tell me exactly what changed. And there's also, you don't have to use a text editor. I mean, if you're a GUI fan, there's a lot of nice GUI front ends that will do this for you. But the idea is it makes it really easy to see what's changed and who did what. Now, the other thing is I have a history. So if I do a git log, this is going to show me everything that people have checked in. So these super long values, these are those SHA-1 40-byte values that I was mentioning. Now you can like, if you're a mouse fan, you can double click on it, just paste the whole thing in, or you can just use the first 7 characters. But this is how I refer to each check-in. So let's say that I don't like my last check-in, and I want to revert. This is one way to do it. I can basically reset. So this get reset hard, I'm basically reverting back to the original version. And if I had like, a history of 100 different commits, I could pick any one of those and say, okay, I want to go back to that version. I basically do that head. What did I show? All right, well, in the interest of time, I want to go. But so there's a few things I added in here, and now I removed them. So this, I reverted back to the original version. So basically, this makes it easy to jump around. If I want to throw away some changes or throw away some specific changes, it makes it really easy to do that. The other thing is, no matter how many times I change my mind, let's say I do that, and I'm like, maybe I actually want that. It's a database, so everything is still there, right? So I can do the same thing. I can go back into, I can do a git ref log, basically look in the database, and I can basically go back to these values on the left. Again, those are the first 7 bytes of those SHA-1 hash values. So it's just kind of an abbreviated version. So I basically pick the one I want to go back to. Again, I can do the get reset hard, that value, and I basically just say, okay, now my file is reverting back to there. So I basically can point that at anything, and it will, all the files, all the directories, everything in the version control will revert back to that version. So this can be pretty slick, especially if you have a web framework or a complex program with hundreds of files. They all go back to that moment in time.
So is it, when it's doing that, is it just putting 79B337 now as the end of this, leaving the other one in between? Or is it removing 7B23067?
So yeah, it's a good question. It doesn't remove anything. So the head is basically saying, this is what I'm currently working on. And now if I do commits, it'll kind of branch off from there, and it'll work from there. But if you really get into the weeds, I probably can't answer all the questions, because I've only been using this for 6 months. But the idea is the head is basically where you're working at now on that branch. So I can basically change that pointer to anywhere in the database, and then I work from there. Now this, let me say, I would not do it like this. The better way to do this is with branches, but I didn't want to introduce too many concepts at the same time. So I'll hold off on that for a second, because I wouldn't do this like this. I'd create a branch. Because if I create a branch, then basically I can say, okay, I'm not going to change anything I did. Instead, I'm going to create a total duplicate branch, and then on that branch, I'm going to revert. So now I have two basically identical systems. One is the old one, one's the new one. And I can basically choose to work on the new one or choose to work on the old one, and I can even merge them back together. So you'd really rather do it like that, but let me come back to that. Okay, so GitHub is really easy to get started with. I basically go there. Actually, before I do that real quick, so even before I create an account on GitHub, I can actually clone a project. So cloning is like, for example, let's say I saw Vim 802 is out, right? And I want to install that. I can basically go up to GitHub, search for Vim, find the repo. Basically, once I find the repo, I click on clone or download, and it's going to give me a link. So I just copy this link, I go into my computer, I type git clone, paste that in, and boom, it downloads everything. And now I have it, and if I have to compile it or anything, I can do that. So if I just want a quick and dirty way of getting some tool that I like using, like for example, I use a tool called NetMiko. This is for infrastructure automation. So if I want to grab this tool, I'll basically just go on any system, install Git if it's not already there, I do a git clone and install it, and away I go. Right? So it makes it really easy. Now, the advantage of doing a git clone over just manually downloading something, it's basically like using a packaging system. So I can go to a website and I can just download the installer and install something, or I can just download the source code and make it. But the problem is, what do I do when they update it? How do I fix that now? Now, for some software, when you do the installation, it'll actually try to figure out what's changed and updated, right? Although that's usually an imperfect process. The great thing about Git is, if I actually do a git clone, at any time, I can go back to my cloned repo, and I can say, check the master that you came from. Anything that changed, it'll figure out the differential, it'll pull it down, and then you can basically use it or recompile it or whatever. So the cool thing is, just like with the package management system, this allows you to keep up to date, right? And it only changes what's necessary. Whereas if you just download something on your own, good luck, right? Even if you only have one file, if that file has a few thousand lines, I mean, you're going to go through every time and try and figure out what changed. I mean, it's impossible, right? So that's really the beauty of using version control, is it actually lets you keep in sync with stuff. It does all the hard work for you. Okay, GitHub, totally easy. You just go there, create an account. You know, if you don't want to give them your email, you know, create a Gmail or a Yahoo account. Okay, and then this is that intro to sprinting talk I mentioned. So this is actually, this is forked from Chalmers Lowe's. I just did that because if you guys actually want to try this out tonight and fork it, then you can basically make changes and submit it to me, and I can approve them, so you can just kind of go through the process of how do you actually download something, change it, push it back, and submit the changes. So if you want to do that, you're welcome to. So if I want to participate and work on any open source project, all I do is I go to GitHub, I search for the project, find it, and then in the upper right-hand corner there's this fork button. So, anybody know the difference between a fork and a clone? Okay, so it's similar. Basically, the difference is if I do a clone, I guess I can kind of see where it came from, but it's a little easier in GitHub. If I do a fork, there's always going to be a link back to the original source, so I can actually see where it came from, and that also makes it easier for me if I want to contribute back to that project. So if I find something interesting and I decide I want to make some changes or maybe do some documentation or something like that, find the project, I clone it, and basically I'm going to clone it on my local PC. I do that git clone. Go back a second. So I find it, click on this clone or download, again, put this in, and at the command line just type git clone and that project. And I'm going to pull it down. Okay, once I pull it down, well, I get one other thing too. I know there's a lot of details to remember. When I have a repo in GitHub, it's going to be something like, something like Vim, right? When I do a git clone, it's actually going to create a new directory called Vim, which matches the repo name in GitHub. I mean, if you mess it up, you can just delete and start over again. So then when I clone that down, I can basically change any one of those files. Like in our example, we have an easy one called authors.md. You can just add your name into it. Once you make a change, I can then push it back. So let me try and walk through this at a high level. So I have something like, let me try and think of a simple example. Let's say I have a static web page that's on GitHub, and I want to change that static web page. So I find that static web page, and in the upper right-hand corner, I'm going to click clone. When I click clone, that's basically going to create an identical copy on my GitHub account that's linked back to the original, right? So now I have a copy of that web page. Then I can go to my computer, whatever it's running, I can do a git clone and basically get that URL and basically bring it down. So what I'm doing is, I'm getting that static web page into my GitHub account, and then I'm bringing all the files down onto my computer. Then, once I get, so let's say there's just one index.html page. Once I get that on my computer, I can use whatever I want to edit the page. I make any changes I want to make. Then what I do is, in my where I did the git clone in that directory, I just say get push it back up to GitHub, and we're going to talk about these in a minute. But I don't have to understand this to do it. I literally just type that. What that phrase does, that's going to take the file I changed, it's going to push it back up to my GitHub account.
Then why would you choose between cloning or forking?
Pardon me?
What would make you choose between cloning or forking?
Okay, good question. So yeah, I don't think I completely answered this. So forking is basically something you do on GitHub. So when I fork a project on GitHub, it's just like a clone, except it does it in GitHub, and it's linked back to the original.
So it's in GitHub is where the link is.
So in GitHub, I can either clone or fork from GitHub, either one. I'm going to clone to my computer, and I'm going to fork to GitHub. But the reason I fork to GitHub is it's linked back to the original. So let's talk about the Vim presentation next week. So let's say that the gentleman does a presentation on Vim next month, and you're like, wow, this is great. I really like this feature, but it's not very well documented. So I'm going to go to GitHub. I'm going to search for Vim. I'm going to clone it. Then I see in the web documentation this one feature that I like isn't documented. So then I'm basically I fork that. So now it's in my GitHub account. When I clone it, I bring it on my computer. I can edit the documentation. When I'm done editing it, I push it back up to my GitHub account. Once I do that, then I can do what's called a pull request. I'll get to that in a minute. The pull request goes back to the original Vim owner and says, hey, this person has added the following documentation. Would you like to accept it? And then the documentation is updated. So that's kind of the whole process. So the fork is I want to copy it in GitHub. The clone is I want to put it on my computer.
Safe to say then the fork, you want to kind of copy it and move it in a different direction like a branch, whereas to actually clone it, you may actually write back to the original file when there and back, and literally has to be approved by the original office and all that.
Yeah, yes, except a branch is a little different. Because a branch is, the best way I can think of to explain a branch is, I guess I spend more time on the infrastructure side. So it's kind of like, imagine I have a content filter at home. I have young kids, and so I set up a content filter at home, and my partner and I agreed that this is what the kids can get to, and we set up all the rules. But then let's say it keeps coming up with new features, and I want to test some stuff out. So then I can create a branch, and in the branch I can say, okay, in my test lab over here, I'm going to try all this crazy stuff. But I'm doing it in the branch. The original master branch I'm not messing with, right? Because that's like production. But my dev or my test branch, I can try all these new features out without fear of breaking anything over here. But I essentially have two duplicate copies that are independent. The clone is a little different because the clone is you're basically just taking something like Vim and you're copying it from the original developer into your account so you can play with it. But it's not the same as a branch. A branch, you would own both branches. Does that make sense? Okay.
Until you added that last statement, I thought I understood the difference between clone and branch. I thought clone was cloning to your local machine and branch was putting it in your GitHub account. Now you're saying that the clone puts it in your GitHub account, so now I'm totally confused.
Well, give me 1 second, because I have a few examples coming up, and I'm hoping this will help a little.
Wondering.
I should have done like a nice big chart. So basically, if I have something like Vim or jQuery or something like that, right, and I want to contribute to that project, so and I'm probably changing the terminology. So I start out, I search for the project that I'm interested in on GitHub. So the fork is saying, I want to take a copy of that entire project and I want to put it in my account so I can play with it.
Right.
The clone is, now I could actually work on it from GitHub. You know, if I'm comfortable doing everything in the web,
Yeah.
you know, for like maybe for something small and simple.
You can
that-
have your GitHub be your master.
Yeah, you know, maybe for something small and simple, but for anything moderately complex, it's gonna get old, right? So probably for anything complex, I'm gonna wanna bring it down to my computer.
Mm-hmm.
So the fork is just for GitHub. The clone is if I bring it down to any system. Like if I have like a Linux or an OS 10 or a Windows computer, I'm gonna clone it.
Mhm.
Then I can use whatever. I can use Vim, I can use Emacs, I can use Sublime, I can use an IDE, whatever I wanna use to edit it. When I'm done with those edits, I'm gonna push it back up to GitHub.
Mm-hmm.
And then from my GitHub account, I can do what's called a pull request to basically say to the original person, hey, I made these changes. If you want them, you can merge them into your code or into your repository.
Okay, so I was right, that the fork is to your GitHub account and the clone's to your local machine.
Yes. Yeah, I apologize if I switched the
So
switched
fork
the
is
terms.
a GitHub command, clone is a Git command.
Yes. That's a good way to put it.
Interesting.
Okay, and then this is just, so one thing that confused me for a while is there's a GitHub pull request and there's a Git pull request. So Git is basically, if I do a Git pull, I have some kind of a repo and I'm downloading from it. If I do a Git push, I'm uploading to the repo. Now from GitHub, it's totally different. If I do a pull request from GitHub, it's kind of like backwards. I'm basically saying to the original owner of the project, I made some changes, would you like to pull them in? So it's really more like a push request, right?
Spoon.
I guess it depends on whose point of view you're
Depends on
looking
You're
the
at.
asking the
Yeah.
author to pull it.
Yeah, you're asking them to pull it in.
It's like you're playing games with semantics.
Yeah, it's, I guess you have to kind of get used to it. And then basically when you do your pull request, you want to give kind of like a nice one-line summary, and then you want to talk about here's what I did. Now, I will come back to this. What you want to see is it's a clean merge. There's no conflicts. If there's conflicts, I can virtually guarantee you they won't accept it. But let me come back to that one because that's much more involved. Okay. Once I have a GitHub account, so in the upper right hand corner there's a little plus sign. I can just click plus and click new repository to create something. You know, I basically pick a name to call it. You don't want to use spaces, you know, use underscore dash. So pick some kind of a short, meaningful name just like you would a directory. I'd put some kind of a comment in. Then basically, once you have that, you can clone that and work on it on your computer. So that's one workflow. I create my repo in GitHub, I clone it down, and then maybe I build my website, maybe I build my scripts, I build my infrastructure, my source code base, whatever. And then I can push it back. Okay, so couple common questions. And there, you know, this is pretty involved. The cool thing about Git though is you can start out with doing pretty simple stuff, and then what you'll find is every time you're like, wait a minute, how do I do this? You just Google it, and basically on Stack Overflow, somebody will say, here's how you do it. And really, you can get really far that way. And then if you're curious, you can actually go. They have an awesome book on GitHub.com. It's like the full-blown commercial book, but it's there for free. So if you're really curious about how something works, you can dig in. But for the most part, you don't have to. It's pretty easy. So, common question is, why do I have to create the repo in GitHub, and then I have to do something in Git? Can I just do everything from my computer? And the answer is you can, but GitHub is not the same as Git. GitHub is a cloud service. Git is like a command line tool. They're not the same thing. Now, GitHub has an API, pretty much like any other cloud service. So, using your favorite programming or scripting language, you can actually write a script or a program using their API that will do everything remotely. But Git does not have that. You would actually have to write a script or a program to do that. So it's possible, but you'd have to do some work, or you'd have to find somebody else's. Why use GitHub? So, I mean, you know, like I said, when my hard drive failed, I was very grateful that I used GitHub for all my documentation. So it's really nice to have some kind of a backup. The other cool thing too is, how many people only have one computer? So a few, right? Well, most of us though, we have multiple systems, right? So let me ask you a question. When you're doing scripts, or when you're, how many people use Linux? How do you keep your dot files synchronized?
Your what files?
Your dot files.
Configuration.
So all your configuration files, how do you keep that synchronized, or how
I'm
do you?
embarrassed to say this, but I use SVN.
Oh, that's a good answer.
At least
So,
you have revision
I don't.
control. Better than me. I don't.
yeah, okay, but so here's the thing.
Email them.
Okay, how many of you have spent more than an hour customizing your configuration on your system?
Oh my gosh.
Okay, so what happens if your hard drive dies? What happens to all that configuration? Did you document how you did it?
Go to your backup.
And if you have a backup, that's a reasonable answer. The nice thing is, and you'll see this is popular on GitHub, I can basically take all those configuration files and I can push them up to GitHub. That way if I find, like for example, if I go to the talk next week and I find 10 cool macros in Vim, put them in GitHub and sync them to all my computers. None. Right? So the cool thing is, when I have multiple systems, it makes it really easy to sync between all of them. And every system has like its own line encodings and like, binary and ASCII formats and all this other stuff. GitHub just deals with that. So I constantly flip between Ubuntu and Windows. And I don't have to worry about, converting line endings and stuff like that. It just does it for me. So it's really nice if you work with multiple systems for keeping everything in sync. So I found that's a huge advantage. The other thing you'll run into is whenever you create a repo, the default is public, which means anybody can see it. So for casual stuff, it's fine. But for your work, probably not so much. So you can also do a private repo, and that's their business model. If you get a private repo, you have to pay for it. There's a monthly fee. So I think it starts out at like $7 a month, and it goes up from there. So it's not bad. So, but there's lots of options. Okay, branches. So, this is actually something that I think I was never clear on until I got into Git. The idea with the branch is, and the best way I can think of this, maybe that hopefully will make sense for everybody, is imagine if I have some kind of a website or a web framework. So if I have a web framework, it's actually a fairly elaborate system, right? There's a whole bunch of configuration files and all kinds of stuff that interacts. So, any kind of a moderately complex website is not trivial to set up, right? You're not going to do it in a couple minutes. So typically, if you have any kind of a sizable company, you want some kind of like a stable configuration base, right? If I do, all these setup steps, I know it's going to work. My database is going to work, my website's going to work right, it's going to be secure, it's going to have reasonable configuration, right? So that would be my baseline. Now, nothing is static. So as I'm developing that, I can create some kind of a test branch, right? So when there's a security fix, when there's a patch, when there's a new feature, when there's I want to change databases, I want to add some new JavaScript or something like that, I can basically do all this over here. And then in my test branch, I can basically run that against all of my tests using continuous integration. The cool thing is I do all of this without impacting the main branch. So they're parallel. Now, if I'm happy with this, I can basically merge it back in. And that's a cool thing about Git, is it basically automatically deals with conflicts. I mean, it's not like there's no work. I mean, there is some work, but it's basically designed to merge all this stuff back in. And I'm not limited to one branch. Maybe I want a testing branch. Maybe I want a lab branch to do a special project. Maybe I have multiple customers. I want to have a common base configuration, and then I branch it off for each customer. Actually, one of my instructors, I took a class, and what he did is he had a base class, and then he would have kind of variations on the class. So every class he taught, he would basically do a branch and then change it. So it would always relate back to the base. So there's a lot of creative things you can do with it, but the idea is it makes it easy to do things in parallel and merge things in or try stuff out, right? But you never have to worry about, how do I get back to the safe place? How do I get back to the safe configuration? Or how do I figure out what got broken? That's what's great about this, is it makes it really easy to always have like a conservative setup. Okay, and if you look, you know, and I think with branches, I think it's something you have to do. You have to kind of try it out, maybe for it to click. But for example, Cisco is probably the largest networking vendor, and if you look at all their software, they'll actually show you they have branches. So they have the mainline branch, and then like every time they have a new version, each new version is a new branch. So you'll basically see this is all version control. If you look at any software, at some point you're going to see that this is how it's developed, right? And every time they create a new feature, like a new patch, a new release, they basically have new branches, right? This idea is to have these parallel tracks. Okay, so going back to our test repo that we did earlier, if I type git branch, by default I just have master. Right? So master is basically my default branch. If I don't do anything else, everything sticks with that. So if I want to create a branch, I basically just type git branch in the name. So I can, for example, type git branch simple, and then I created the simple branch. So now if I type git branch, I have two branches. I have the master and simple. The one that has the star that's highlighted, that's the one I'm on. Now, if I want to switch branches, I'd use the checkout command. So get checkout branch. So get checkout simple, I switch to that branch. Now, going back to our example earlier, this is the way I'd want to do it, right? So if I had a static web index file, and I was pretty happy with it, but then I decided to make a bunch of changes, and then I'm like, I don't know if I want those or not. I probably wouldn't revert. What I would do is, I would create a new branch, like this, like simple. And then now I have two branches. Each of those branches have the identical files. So now what I can do is, I can basically, all the stuff that I've done, I can leave that alone, so I have the new stuff. And then in this branch, I can do this git ref log that's going to show me all of my commits. I pick the one that I want to go to, and again, I'm basically, this is just an index into the commit I want to go to. I type that command. Now in this branch, I'm at that commit level. So the nice thing about this is, I have the one branch that has the latest and greatest, and I have one branch that now I've reverted to something that I thought was simpler and better. And I could have 10 branches, 20 branches, whatever I need. Now, this is just for one file, but really this is for everything. So I can have a repo with hundreds of subdirectories and thousands of files, and I can just flip back and forth between stuff. And everything changes, and it's really fast. That was a big thing for Linux, is this had to be really quick. So this is really slick, especially if you have a complex website or source code, and you just want to switch back and forth between stuff. This is a really, really easy way to do it. And the other thing too is, if this doesn't make sense, don't worry about it. You don't have to use branches. It's totally optional. I think most of the benefits you get, branches I think get more interesting, especially as you start collaborating with lots of people. But just using it by yourself, I mean, just actually setting up a GitHub repo and checking in your configuration files, checking in your website stuff, checking in your source code or your scripts, just doing that is really helpful, right? Because just having a history of what you've done, having a backup, having documentation, having logs, I mean, that's already a huge step forward, or at least it was for me. Okay, now, one other thing that's important is, if you do branches, right? So remember we did this get, push, origin, master. I didn't explain that earlier. So when I do a git clone from GitHub, that actually sets up something called origin. So this get, push, or pull, this is an alias. And that alias is just some kind of URI. It's typically a URL. So if I do git remote -v, it's going to list all of my aliases, and it will say, typically that origin is going to point to wherever I cloned it from GitHub. So when I say git push origin master, I'm saying, okay, wherever I downloaded this from, push it back. But notice this master, this is the branch. So by default, I'm pushing it where I got it from, and I'm only doing it for the master branch. So if I have other branches, that does not include them, right? So if I basically make some changes, I push it back, I look on GitHub, and I basically click in GitHub on the left side. I can click on the branch, it'll show me all the branches. Notice the only option I have is master, I don't have simple. because I didn't push it. So it's only local. So if I want to push the branch I created, I have to do get push origin simple. That's basically saying push that simple branch I created up to GitHub. And now when I look, I'll see that I have both. So again, I mean, don't worry if this is a little hazy. You know, if you use it a lot, that this will come later. But just remember this little gotcha, right? By default, you're only dealing with the master branch. All right, the other thing is, and this also might be a little hazy, this is something I think you have to do for it to make sense. If you participate in a project, and you basically, let's say you do some documentation, and you submit the pull request to get the author to accept your documentation, you might see a conflict. A conflict, so most likely what happens is, you have great intentions. You get Vim 802, you're all excited about it, you write this great documentation, but then you get busy, and then a month later you're like, oh yeah, I want to submit that documentation. So you go to submit the pull request, but it's been a month. So there's been a whole bunch of changes, and there's tons of conflicts. And I guarantee you that the author's not going to deal with that, right? He or she is too busy. So what you do is, there's a sequence. By default, when you clone something, you're typically what you're going to do is you're going to, again, like with Vim, you'll find the project, you'll clone it to your account, or I'm sorry, you will fork it to your account, then you'll clone it to download it to your system, you'll make the changes, you'll push it back up, right? Now, if in the meantime you found that the original version has changed, now Vim 803 is out, for example, okay, you're out of date. So now what you have to do is, and typically by convention you use what's called upstream. So this get remote add is basically I'm saying I'm adding a new URL. So in addition to getting this from my repo, from my GitHub account, I'm going to point back to wherever I got this from originally, like the original Vim repo. I'm going to create an upstream. And then what I can do is, once I create that guy, I do a get pull upstream. So again, upstream is just an alias for the original Vim source, and I pull the master. What that's going to do is, it's going to look at everything I downloaded, and it's going to compare it to the updated version, and it's going to find all the diffs, and it's going to bring you up to date. Now, when it does that, you're probably going to have some conflicts, like you saw in that PR. But then it'll basically bring up an editor, and you'll go through and resolve them. Once you resolve all those conflicts, now you're up to date. Now you push it back up to your GitHub account. Now you submit the pull request back to the original owner. Now there's no conflicts, right? You did all the hard work. So again, I mean, this might seem kind of abstract. Don't worry about it. But you know, I'll publish the slides. So if you deal with this later, hopefully this will be helpful in kind of getting you to think how to get through that. All right, so we're pretty good on time. So I'm not going to walk through this. I'm going to put this up. But this, I guess, you know, this is my call to action. So my hope is, you know, more and more as I get older, I'm a pragmatist, right? So for me to consider this presentation a success, I would like all of you to install Git, set up a GitHub account, and it doesn't have to be mine. Feel free to pick anybody's. Download some kind of a project, do maybe some basic documentation, upload it back, and then do a pull request to actually help out some open source project. So pick anything you like. But this is really simple, shouldn't take you, I think, more than an hour tops. And once you start using it, I think you'll really see that there's a lot of utility in this solution. It can really be very helpful. And then also, I threw in a couple reference stuff. I mean, you can Google any of this, but hopefully, in terms of just getting started, those are some good references. So with that, any questions?
Will your slides be available
Yeah.
to the group?
Yeah.
Via
Publish it as a PDF.
Just so I have this clone fork thing straight. We're gonna fork over, if we're on GitHub,
Yeah.
we're gonna fork somebody's project into our own space on GitHub.
Yep.
We're gonna clone from our space.
You can actually clone from either one.
Oh, okay, but if now I'm working on my local machine,
You
my
can
clone
clone-
copy,
Yeah.
I'm
When
gonna
you
push things back to my space though.
So Jim, it's a great question. So now you can clone directly from Vim.
I understand that.
But the challenge is, if I clone directly from Vim, and I go make a bunch of changes and,
Yeah.
and push them back,
You wanna But-
Yeah,
Like I want to fork and be
Yeah.
pushing back and forth between my fork copy and my local.
Oh, you know what, I know what the problem is. Basically, here's the problem, I believe, because I haven't tried to do this, but I believe the problem is this, okay? So if somebody has a repo, like Vim, right, you don't have commit access.
Right.
So that's the problem. So the problem is if you make a bunch of changes, you don't have commit access, so there's no way for you to basically get those, or easily get those changes back. So the reason that you do the fork is if you fork it to your account, now you have commit access to your account.
As long as I clone from my account.
Yeah, yeah. So if you clone from your account, then you push it all back up to your account, then when you do the pull request, he can choose to commit it.
Right.
That's why you do
And he
that.
would pull from your fork copy.
Yes, exactly. One other gotcha too is when somebody, like if you accept a pull request, when you accept a pull request, it doesn't just take what they did when they sent the pull request, anything that's changed since is also included.
Mhm.
So now it'll tell you, when you import it, it will show you what's changing, but just be mindful that you're pulling from that point in time.
Pull request doesn't contain a 7-character hash thing?
I guess that's not how it works on GitHub.
Alright.
Basically, because I've been warned of that, whatever, like that moment you click accept the pull request, it's gonna pull whatever is there at that moment in time. So you know, if you're a repo owner, you gotta.
Yeah.
Now, of course, if you have a more complex project, you can actually set up an organization as opposed to an individual account that's too complex for an intro. And in an organization, then you can have multiple people with commit, and then you can get a lot more along. But that's beyond the scope of this. I'll get to you in 1 second. Yeah.
So, the concept of, as you're just saying, you have an organizational thing, multiple people. So if someone goes on vacation, there's someone who can own that, even
Yeah.
though the main person is not there, so you share responsibility
Yeah.
to pull things in.
Yeah.
Okay.
Yeah, and you can have pretty large groups. Like, for example, in my company, like my group has a corporate repo, and there's 5 people that have administrative rights. So any one of the 5 of us can, do commits or add or remove people or anything like that. And that's a small organization. I mean, you can have hundreds of people. I mean, it's like anything else, right? I mean, yeah, there's probably no limit to how big you can go.
Well, so I'm concerned about understanding for an individual project, right? So your socket duck thing,
Mhm.
is that something that you can have just a certain number of people within your organization who have the right to pull in the code, accept the pull?
If you create an organization, then basically anybody who's an admin can do whatever they want. So you can keep everything private, you can throw people out, you can bring them in, it's very flexible.
I think it's also the difference between a public repo and a private repo.
Yeah.
A public repo, anyone can check out. Private repos, you have to have access in order.
Well, you have to be invited, it's invite only.
So again, the question though is, so now you have to set up a private repo for every project that you're running. So SockDuct has a repo that has administrators do it. You don't have the capability of having SockDuct group owning the code and allowing stuff to be imported only. So that another project within that repo, right, is gonna be something you have administrators all sharing that same repo.
I think it's, it's pretty elaborate, but to be honest, Gib, if you wanna talk to an expert at the organizational level, it's just not something I've done. I
Okay.
could probably find out for you, but I know it's pretty powerful. I know some very big companies that do some very advanced stuff. Hold on 1 second, you had a question?
Actually, at 4, would you like one at a time or all 4 at once?
Oh, shoot. Well, the only thing is, how are we doing on time?
I'm starting to panic, but.
Okay, so maybe, well, at least a few, but yeah, I gotta let Craig start.
I was working for Chrysler, we were looking at Git, we weren't using Git Hub because we wanted to keep the data in-house.
Okay,
All right,
so that's possible. You can have an in-house repo.
right, we had lots of them, okay. We tended though, we actually tended to go more with SVN because of certain things which might have been resolved since. One is, we found the Git repositories tended to grow by the power of the number of users, effectively exponentially.
That honestly I can't speak to. Like if you want to compare 2 different, honestly, my knowledge is not advanced enough to answer your question. I'm not sure.
And it seemed to derive from the tree versus graph structure, graph being Git Up, Git, SVN, CBSV, and tree.
Yeah,
But
I'm not
fork
sure.
is sort of twisting to get toward a tree structure. All right, let's see. There were, one thing was there was a lot of SVN bridges that were listed in, we looked at. Didn't find any good ones then, but they were fairly new. Has there been?
So to be candid, anything with another, this is the only source control system I've really used. So
Okay.
anything with SVN, I mean, I know what you're talking about at a high level, but I don't know.
Okay. Other one was, by design, I understand Git has no security built in, though it does have a good API. Do you know any good recommended tools, add-ons for adding security to?
That's part of what GitHub is designed for. is
There's
to add
also
security.
a project called Git Lite that you can use internally. We use that for determining which users have access to it. And what you do is you have folks copy over their SSH keys to it, and then it knows them by their SSH key, you know, who has access to which particular repos and that.
Okay, that was Git Lite, G-I-T?
Git Lite, Gitolite.
L-I-O-L-I-T-E, thank you.
Yeah, that's one option.
Or you know what, if, probably Craig, I should let you go. If anybody
Sure.
else has questions, maybe see me afterwards, just so you can get started.
Very nice done.
Thanks, Joe.
Thank you, Jim.